Yes, teacher Navasa at the Riverfront International. And today we are going to look at one of the items in UCE Chemistry 2024, paper 1, and we are going to look at item 2. Previously we have looked at item 1 and we have revised it many times. Now today we want to look at item 2. We are saying that an industry wanted to produce lime, so we are going to underline lime for treatment of acidic soils. So it is a component of acidic soils. The production of lime involves heating limestone, so we also underline limestone strongly, which results into its decomposition according to the equation. Now, those of you who didn't learn equations, you are going to stop from here to understand this question or this item. The industry is also interested to know how much gas is available during the process, since the gas is useful. Now, before the production, an experiment was performed where 25 grams of limestone were heated until there was no further change. You have been contacted for help. Task A. As a learner of chemistry, explain the categories of the products. Now, remember, when they give us an equation, in an equation we have two parts. We have this part, which is usually the one of reactants. This side of the equation has reactants, and this side has products. We base on this arrow of forming. So these are the ones that were involved in the reaction. These are the products of the reaction. So they want us to talk about the categories of the products. So number one, we are going to first identify the products. So according to our equation, which are the products? The products is calcium oxide. In the equation we write it like this, and carbon dioxide, and in formula we write it as that. Now those are our two products, so they want us to categorize them, which means we're going to categorize calcium oxide and also categorize carbon dioxide. So which one should we start with? Number one, let us start with calcium oxide. Calcium oxide. Where do we start from? We first go and revisit the work of senior 2, and we look at bonding and types of compounds formed during bonding. Now, you realize that calcium is a metal, but oxygen is a non-metal. What does this tell us? It tells us that this calcium oxide compound was formed between a metal and a non-metal, and therefore category number 1, calcium oxide, becomes an ionic compound. We want to go ahead and give reasons why are we saying that actually calcium oxide is an ionic compound, because it was formed between a metal and a non-metal. Usually, you can also say it was formed by the transfer. It is also formed by the transfer of electrons. More especially the valence electrons, the electrons in the outermost shell of an atom. So you realize that being a metal, calcium will lose its outermost electrons, while oxygen, or being a non-metal, will actually receive the electrons, and therefore the bond formed between is an ionic bond, and the compound becomes an ionic compound. Now, category number 2, we can put where we can put calcium oxide. Calcium oxide, we remember the types of oxides. We have acidic oxides, we have basic oxides, we have amphoteric oxides. So of the three, basic oxides, then we have amphoteric oxides. These ones have both basic and acidic properties. These ones have basic properties. And then we also have what we call acidic oxides. So among these oxides, calcium oxide becomes a basic oxide. So we are going to say that calcium oxide is a basic oxide. Why do we say so? We say so because this calcium oxide reacts with water, reacts or dissolves in water, reacts with water to form an alkaline solution. Alkaline solution. So those of you who know how to write equations, you can come and say calcium oxide, which is a solid state. Then we come and say plus water. Now for them, when they react together, they will form calcium hydroxide. Now this one is the alkaline solution. Now those of you who do not know how to use symbols, it's okay. You can go and write a word equation and say calcium oxide plus water forms calcium hydroxide, which is the alkaline solution. So this is the alkaline solution we are talking about it. Later we are going to see how it relates with pH later a bit. Now we can even, since now we know that calcium oxide is also an ionic compound, it means we can also categorize it by its state of matter. Since it is an ionic compound, it will be a solid. So category number 3, calcium oxide is a solid compound. However, I could have also combined it with the upper part, but I have actually now categorized calcium oxide. So number 2, we are going to categorize carbon dioxide. By state of matter, carbon dioxide is categorized as a gas. Yes, it is a gas. We all know that. Now, number 2, carbon dioxide is among the oxides. When you count oxides, it becomes an acidic oxide. Why do we say that carbon dioxide is an acidic oxide? Because when this gas is passed through water, what happens, its interaction or its reaction with water will result into an acid. Let's look at it in an equation. When you have carbon dioxide, the gas, and you pass it through water, which is a liquid state. Now, we can use a free equation, but we can also use a double equation because it can convert back. So any of the two will work at this level. So I will choose any. I can use one, and what will be formed is carbonic acid in aqueous state. And the equation is well balanced. You have 3, you have 2 and 3, hydrogen there, 2 hydrogen there, 2. So that is why we say that carbon dioxide, 1 is a gas, number 2 is an acidic oxide. Number 3, we want to come back to ionic compounds, covalent compounds. Then we also come to metallic compounds. All these ones are taught under bonding. So we want to see this is an ionic bond between ionic compounds. These are covalent bond between convalent compounds, and this is a metallic between metallic compounds. So now we want to see which of these among the three provided, where does carbon dioxide fall? Now we want to look. Carbon dioxide is a what? Carbon dioxide is made up of carbon, which is a metalloid. It's a metalloid. A metalloid, others call it a semi-metal. Yes, and which means it is not a metal, it is not a non-metal. But most of its properties will fall under non-metals. Then you also have oxygen, which is a non-metal, which means that these two cannot form an ionic compound. They instead form a covalent compound. A covalent compound. Why? You'll come and talk about, because it is formed between carbon, which is majorly non-metal, and then oxygen, which is also a non-metal. So here we have actually categorized these products which were formed after heating: calcium carbonate, which is the limestone, and then calcium oxide, which is the lime they are talking about. Calcium oxide is also sometimes called quick lime. That's why we call it lime. So please, anytime you meet quick lime, don't get worried. So this was part A of the task of this item. Now we want to continue and go and look at part 2. We look at part 2. What does part 2 tell us, or part B? So part B is saying that suggest the properties of the gaseous product that make it useful in daily life. So what is the gaseous product? Is the one we want to first identify. So the gaseous product of this reaction is carbon dioxide, as we can see here, because we have two products. We have calcium oxide and carbon dioxide, of which we have said that of the two, carbon dioxide is a gas and this one is a solid. Okay, so what properties? So we want to look at properties of carbon dioxide that make it useful in daily life. Number one, we all know that carbon dioxide is used in fire extinguishers. So we want to know what property does carbon dioxide actually have that make it be used in fire extinguishers. Number one, it does not support burning. It does not support burning. It does not support burning. And therefore, it is used in fire extinguishers. And therefore, it is used in fire extinguishers to do what? To put out fire, or to extinguish, or to put out fire. So where is the use in daily life is putting out fire. The property not supporting burning, and therefore it is used in extinguishers to support burning. Which other property or which other use of carbon dioxide that can also help us in? Number two, it dissolves in water. That is one. When it dissolves in water, what does it mean? It means it makes it easy for use in beverage preservation. In beverage preservation. I know most of you have ever opened a bottle of soda, a bottle of any carbonic drink. Now, that's what happened. Then we also have a unique one, for example, number 3, which I'm actually going to end with, and you are going to add others in the comment section. It can diffuse it can diffuse. This one can actually be related with dissolving in water, and hence can be absorbed, and hence can be absorbed into leaf cells, for what? For photosynthesis. This is one also of the characteristics that make it useful in the daily life. Since it can easily diffuse, its particles are very small, it can easily diffuse into cells, and therefore it can be absorbed by leaf cells to be used in the process of photosynthesis. Now, remember here they told us that the industry is also interested to know how much gas is evolved during the process, since the gas is useful. And here in part C, they are telling us that calculate the volume of the gas produced, of the gaseous product measured at STP that was formed. Usually, I want to tell candidates, once you see a number like that, always come and check here. There is this part here on front of the paper where they say use where necessary, calcium equals 40, carbon equals 12, oxygen equals 16. Then 1 mole of a gas occupies 22.4 decimeters cubed at STP. This is not actually put out for fun. It is one thing that you will need to do numbers like this, because they know you are going to be needed somewhere. So if we want to calculate this number first, we need to know what is going to be heated. What is going to be heated is calcium carbonate, which is the limestone. Now, what do we want to get is the gaseous product, which is carbon dioxide. Therefore, we will start by calculating the relative formula mass of calcium carbonate. Others call it relative molecular mass. So they have told us that calcium is 40. How many atoms of calcium? 1. So it is times 1. Then you come to carbon. There is only 1 carbon atom. And they have told us that carbon is 12 times 1 in brackets. Then you say plus. We have oxygen. They said oxygen, there are how many? They said oxygen, there are 16 here. So we are going to come and say 16 times how many? There are 3 atoms of oxygen in this, times 3. Then you come and add. So you get 40 plus 12, which is 52. I think this is 48 plus 48. So what does this give us? It will give us, it means this is this one plus this 50, 60, which makes it 100. Sometimes we put grams, sometimes we don't put, but we can stop there. But this one is the amount of mass contained in 1 mole of calcium carbonate. So that's why sometimes when we come here and we're talking about 1 mole, that 1 mole produced 1 mole, don't say where has it come from. So we want to come back to here. So we come to the equation. Our equation, let's first write it here, is calcium carbonate solid state. When it was heated, it released calcium oxide solid state plus carbon dioxide. It's a gas. Now, since we have 1 mole of calcium carbonate, if there is nothing here, we put 1. If there is 1 here, there is 1, and there is nothing here, there is, so it is 1. So we can realize that 1 mole of calcium carbonate actually produced also 1 mole of carbon dioxide. So we are going to come and say that 1 mole of calcium carbonate, others say produces, but me I'm going to say produced. 1 mole of carbon dioxide. 1 mole of carbon dioxide. But we know that relative formula mass or relative molecular mass is equal to 1 mole of a compound. So what I'm going to do, I'm going to say that this 1 mole is equal, let me say, but 1 mole of calcium carbonate is equal to what? Is equal to 100 grams, which is the relative formula mass. So I'm going to come and say that 100 grams of calcium carbonate are produced 1 mole of carbon dioxide. But here they told us that 1 mole of a gas, which is the carbon dioxide, occupies 22.4 decimeters cubed at STP. So I'm going to come back and say, but 1 mole of a gas, 1 mole of a gas occupies 22.4 decimeters cubed. Okay, so which means this 1 mole of carbon dioxide is the gas, can be replaced by this one, and then I already have this statement. So I will say therefore 100 grams of calcium carbonate produced. What did it produce? 22.4 decimeters cubed of carbon dioxide. Now, if I want to take it more higher, what I will do, I will come and say, remember what was burnt was 25. So I can first put 1 here and then I continue. But let me first do this. It was 25 grams which were heated. So I'm going to come and say about 1 gram of calcium. If I was the one calculating, I would have finished it, but because I want you to follow step by step, that's why I have not finished it. I want you to see step by step. So produced 22.4 divided by what? Divided by 100 times 1 decimeters cubed. Now our space is covered here. Let's summarize it from this side. Then we are saying, if we have, this is 1 gram, how about 25? So we'll say 25 grams of calcium carbonate are produced. What did it produce? 22.4 divided by 100 times 25 decimeters cubed of carbon dioxide. Then from there we calculate. Then we get, and then of course after calculating you get your 5.6 decimeters cubed of carbon dioxide gas. Then you come and say, therefore 25 grams of calcium carbonate produced, others can say produces 5.6 decimeters cubed of carbon dioxide gas. As simple as that. So I think you are able to follow step by step. Now we want to look lastly on this part D, and we are saying explain the impact of one of the products on the environment. Now we are going to talk about both of them. Now I'm going to start with carbon dioxide. Carbon dioxide. Now most of you, when we say the impact, it means can either be negative or positive, but let me start from the negative. Now, remember that excess carbon dioxide increases the amount of green gases. So green effect gases. So it means that increases increases greenhouse effect. Why? Because carbon dioxide itself is a greenhouse gas, and therefore leading to, for example, increase in temperature or Earth's temperature. Full stop. Now this one, how does it come about? The more the carbon dioxide is released into the environment, the more it destroys the ozone layer, and therefore the more heat is captured under the sky, and therefore we experience a lot of heat, something we call greenhouse effect, something related to that. How can we mitigate this? Number one, by planting more trees. By planting more trees, which is, I think, afforestation. Why is this one important? Because when more trees are planted in this environment where this industry is being used, the trees are going to absorb more of this carbon dioxide for usage in photosynthesis, and therefore this gas will not be able to accumulate in the atmosphere. Another mitigation we can look at will be capturing the fumes containing carbon dioxide, such that it does not go into the environment. So there are different technologies these days where they can get this one. Now let me go to number two, which is the calcium oxide. I'm just summarizing. You can add more in the comment section. Calcium oxide, remember I've said it is a quick lime. Now if used in excess, it can increase pH. It can increase soil pH. Let me say soil pH. And remember, soil pH affects soil fertility. Not only soil fertility, but also the living organisms. The living organisms living in the soil, they live there because of certain pH. So if pH changes, it will not be able. How can it be mitigated? By treating industrial waste before it is released into the environment. I've just given hints, chap hints. You can add more in the comment section. Thank you very much for following. My name is Teacher Nabasa here at Riverflow International. Do not forget to subscribe. Do not forget to share with a friend. Do not forget to ask questions or send us your questions. Thank you very much.